All right, so with all of that information of solving trigonometric equations, let's look at some applications. These can be quite a bit simpler, because with those trig equations we've looked at so far, we were looking for all possible solutions. With word problems, we're usually a little more restricted in terms of wanting only positive values, and only certain positive values will make sense. So with context, the amount of solutions kind of becomes more limited. Now, typically with word problems, I'm going to say typically because not 100% always the case, but most of the time with these, we're going to be working in degree mode. So everything we did so far was all with radians, and that's how we typically work kind of abstractly with these. When we get into applications, measurements in the real world are more commonly in degrees. So with that, we'll be switching back to degree mode here. So just always be sure to check that mode on your calculator when working with these. All right, we have an airplane. It only has enough gas to fly to a city 200 miles northeast of its current location. If the pilot knows that the city is 25 miles north, how many degrees north of east should the airplane fly? So the pieces we have here, we're going 200 miles northeast of our current location. We know it's 25 miles north. And what we want to find is how many degrees north of east are we flying? So to help me visualize this, I'm going to make a picture. So we have our current location, and we're flying northeast. So if it helps, you can make yourself a little compass here. So it goes northeast, southwest. So we're going northeast, which means we're somewhere in here, and that's what we're trying to find out. Like, are we super close to north? Are we super close to east? Since I don't know, I'm just going to go ahead and draw it in the middle, but just know that this angle measurement isn't really drawn to scale because that's what we're solving for. So what we have is that we're going to fly in a northeast direction for some time, and that distance, and imagine that's a straight line there, we're ending up in this city, whatever that city is, and that is 200 miles. Now, something they also told us is that we know that that city is 25 miles north. So I know this distance here, just going directly up, and if we went over from there, just that distance up north is 25 miles. So we're getting these pieces here. We have these 25 miles from our current location, and then we have these 200 miles, ooh, I missed it a little bit, in this northeast direction. And then we didn't really talk about this distance directly east, and it doesn't really matter. When we're working with these, just based on the relationships of SOHCAHTOA, sine, cosine, tangent, we only need 2 measurements. And then something I should make note of is that this is a right triangle, which means I can use sine, cosine, tangent. I can only use those for right triangles. So the wording here, we want to find how many degrees north of east. What that's describing on our compass, the number of degrees north of east. So it's like east is our standard position here. And then we want to see how far north of that are we going. So the angle I'm interested in here is actually this angle measurement. So let's go ahead and call that theta. That's what we want to find. However, that's outside of the triangle. So what I'm going to do is, in solving, I'm going to use the fact that these 2 angles are going to add up to 90 degrees. So what I can do is solve for this angle inside. Let's just call it x. What I can do is focus on finding this angle measurement here within the triangle, and then use the fact that when I need to solve for theta, it's just going to be equal to 90 degrees minus whatever that measurement for x is, since those are complementary with each other. So We'll have a little bit of extra work there, but in terms of the triangle, I want to find this angle measurement. So if I'm standing here at x, that means that 200 miles is the hypotenuse, 25 miles is adjacent. So working with adjacent and hypotenuse leads to cosine. So I know that if I take cosine of that angle x, we're taking adjacent over hypotenuse. Now, I want to know the angle measurement. And with word problems, as we start getting all of these skills of working with word problems and trig functions, if you ever need to find an angle measurement, you're going to be using inverse trigonometry. These cases with right triangles that we looked at before, it was all about solving for side lengths. And if we solved for angles, we always had one. It was just solving for one missing one, which was just using that property that they all added up to 180. Here, it's going to be that we need to solve for an angle measurement, and we don't have another one to use. So with that, we're going to inverse trig. So this right here, and you could simplify this. We don't need to because we're going to be going to a calculator. We're going to need a calculator to help us out here. But I want to solve for that angle measurement by taking inverse cosine of 25 over 200. So I need to go to a calculator. And let's see, I had that I was working on before. Now I'm in radian mode. I need degrees. So I'm going to switch over to degrees. I'm looking at inverse cosine of 25 over 200. And that's where it doesn't matter if that's reduced or not, because we just want that angle measurement. Now be sure to check the mode you're in. Like if we were in radians, that would make it look like a much smaller angle of 1.45 degrees. So just keep in mind what mode it's in, because really it's 82.82 degrees. So x from the calculator is equal to, let's go to 4 decimal places since I still need to use this number for calculations, because that gave us kind of this angle measurement between, it's not even between anything. So it's just kind of like from north, but we want to look at how far north of east we're going. So that's where I need to do 90 minus that value. So to get that angle measurement theta, we take 90 minus the 82.8192, plug that into a calculator, and that should be about 7.18. So that would be 7.18 degrees of, or let's say north of east. Which makes sense in terms of this triangle. Like we have this I didn't draw this to scale at all. We have this very long side compared to this very short side. So it makes sense that that angle measurement's teeny tiny in there. So what it really takes is having a good setup of a picture, and then these ones that deal with direction of north, east, south, and west, just pay attention to the wording and kind of how it's phrasing the different directions. All right, this one here, we're looking at the loading ramp on a truck. So it has a height of 2 feet, and the ramp is 200 feet long. So if I just draw a triangle for this, this is the ground. Oof, sorry, my straight lines are way off today. That's a little better. And then here's going to be the ramp. I'll just do kind of a zigzag. This is a purposefully terrible line there to show the ramp. Oh, my drawings. So the height of the ramp is 2 feet, and the length of the ramp is 200 feet. And then this is just the ground down below here. Here's the ground. All right, so what we want to find is the angle with the ground. So I want to know what is this angle measurement right here. So let's see, we know opposite, we know hypotenuse. So with that, I want to use sine. So sine of that angle theta is going to be equal to opposite over hypotenuse. And since I want to solve for that angle measurement, I'm going to use inverse sine. And with that, I'm just going to the calculator. So from the calculator, inverse sine of 2 over 200 is a 0.573, or 0.57 degrees, which makes sense. I mean, that's so small, but think of the comparison. This is a super long ramp with a very short height. Like, I should have stretched that drawing way out further, and that would make a teeny tiny angle. So it's a very low grade ramp that they're going up and down there. So there's some examples of word problems. Drawing out a picture can help. And then if they're looking for an angle measurement, then you're using inverse trig functions, and it's kind of solving an equation. If you're solving for the side lengths of the triangle, like if you know one of the angles already, then that would be using our standard trig functions. So if you have an angle to input in there, then you can solve all of that without going through this. But it's these cases where we need an angle measurement that we're using inverse.